Right, next I'm going to run through a number of different differentiation problems. So the thing that I want to highlight here is that it's not always going to be, f dash x, or it's not always going to be dy dx. We have to make it so it is relevant for the letters that we're using. So here we have y equals a to the power of 4. That means that my derivative should be written as dy dA. Okay, because y in terms of a. And using the same strategy as before becomes 4a to the power of 3. Done. The next one is in terms of x and t. So it's x in terms of t. So it's going to be written as dx dt. And that's going to be equal to 2t minus 3. So again, power is going down the front and then decrease the power by 1. And with this term here, the 1 goes in the front and then it decreases to 0, so the t just disappears. The next one should be dz dy. So the 6 goes out the front with half. Half of 6 is just 3y to the power of 5. Okay, the 5 goes out the front with the 1/3, so it becomes 5/3 y to the power of 4. The next two are a little bit more complicated. So in this one here, we've got just y in terms of x, so it's going to be dy dx again, but before I can do that, I actually need to do some, fixing up of this thing. You notice that this is a division problem. We didn't have any rule for dealing with division. So when this happens, we actually just need to divide through the terms. So first things first, it's going to be y equals x to the power of 2 minus 4x. Okay, so I've divided each of the terms by x. And now I can figure out dy dx. So it becomes dy dx equals 2x minus 4. And the last one, again, we didn't really have a rule to help us with differentiating something like this. So we've got a function multiplied by another function. We were able to do it when it was multiplied by a constant, but that's not so good in this particular situation. So first thing I'm going to do is expand out the brackets. So it becomes t squared, then we've got minus 7t and plus 4t makes it minus 3t and minus 28, which we can then differentiate. So we get dp dt equals 2t minus 3. Now there's probably one more thing that I should go into. In this question I asked you to differentiate these things. There is another way that you can be asked to differentiate something. So that's using operator notation. So I'll just say evaluate d dx of 4x to the power of 5. Just for a nice simple one. Okay, this is the operator here, and this is telling us that we need to differentiate whatever is inside these brackets here with respect to x. Okay, so it had to be d dx because we were dealing with the letter x in the problem. And we just go and we differentiate what's here, and so it becomes 20x to the power of 4. Now, this is the notation that you'll experience when you go to use the calculator to do something like this. So I'm going to go just back and into Math 2 where I have all of my differentiation buttons. And you see right here I've got d something. So I'm going to make it d dx of 4x to the power of 5. And if I hit execute, it is 20x to the power of 4. So that's called operator notation. But that's all I need to do in this video, so we'll leave it there.